the co-founder and CEO at KYVE. I'm a software developer since a few years. Got into crypto space in 2019, I would say, at a hackathon, and then got deeper and deeper into crypto in 2020. That's when I met John, also the co-founder of KYVE. We developed a few products together on the Arweave side, and then February last year, actually, we started working on KYVE, and now this is a bit of our story here. So this talk's going to be rather quick. It's going to be like 10, 15 minutes-ish of like a demo and a quick presentation, and then we're going to do like a 10-minute Q&A session. Feel free to ask like any questions, project-related, anything. I'm happy to get it rolling on that. So basically, one of the fundamental problems in blockchain is that it's super, super hard to get access to the data due to like different reasons, and it's actually also implemented by design. So we know that indexing and retrieving large amounts of data is a tedious work, because basically what you have to do, right, is you have to connect to the chain you would like to get access to. You have to pull down all the data. It's usually done in a centralized way, so it's in centralized databases. You're serving then the data out of that, and then you still have the problem that the data is very condensed as well, right? You cannot cache, and I think there's another point on there, right? You can't cache the straight transition, so you can't just ask the blockchain like, hey, what's the total value locked on, for example, this DeFi pool, right? It doesn't work. You would have to like compute through every of the transitions to then get the latest value. The transactions are also very, I think it's also a point why crypto hasn't seen like the worldwide adoption yet, right? It's very, very cryptic. You just have addresses, so you have to figure out how that stuff works. You could build some fancy indexing things around that, and then it's still a problem. It's only in a centralized database, right? And we know that like the backups or snapshots which are centralized are not reliable, because who are you going to trust? I mean, if you as a foundation are doing a snapshot, that's probably the most trustful source you have in this like non-trustable system, because I mean, what happens if they modify it, or what happens if while they doing their transfer, something went wrong, and it's not even on intention, but then when then the chain would load in the backup, right? You have the problem, you would load in incorrect data, and then actually no one really knows what's going to happen at that point, right? It's like the chain going to halt, is it going to continue? So it's like a really, really big problem getting the data integrity and data availability correct. And then also the cost of distribution is super, super expensive. And I think most of you guys, I would assume, are developers. So I think working with Solidity and working with smart contracts, we know it has become like a real art, actually making contracts using as less storage as possible, right? Especially on EVM, like the storage cost is crazy, crazy expensive. And this leads then to problems like that we have to store the NFT metadata, not on chain, but storing them somewhere else, right? Putting our assets basically effectively at risk, because it's like it's implemented by design that storage is expensive. And so this is kind of like the main problem KYVE can target. And the way it works is that we have those storage pools in which we have a decentralized set of nodes which would basically listen to the data. They take the data from the foreign API. It can be an API, it can be a blockchain, it can be whatever really the developer wants. Then they take the data and then store it on decentralized storage. Right now we are utilizing Arweave for that. It gives us a lot of flexibility as developers, because I mean, Arweave is very, very cheap, and it allows permanent storage too. And so this is kind of like the core idea. And then maybe to dive now a bit deeper into it, let's take the example of storing like some block which has been produced on the Avalanche seed chain. So the way it usually works is we set up an Avalanche pool, and we see this in the demo in a few seconds as well. We then connect to the nodes in the network, and then the nodes produce reliably blocks. And then the uploader in the storage pool takes the data, stores it onto Arweave, and then registers this in our logic, saying, hey guys, I've uploaded this piece of data, could you please validate it? And then all the other nodes, which are our validators, they get along, they fetch down the data, they run a validation check against it. So the easiest check, for example, is, does A equal B? And if yes, right, they vote in favor for the piece of data, saying, well, this is what we want. And if not, they vote against it. And then so it's like it's a proof of stake voting system on data. And this allows really to store any type of data structure, right? It can be EVM data, it can be like a normal API data. I think one really nice example we have is actually storing the API of the European Central Bank, which is a currency conversion API, which is super, super useful, because what we then do with all the data, we're also building at the same time as like a side effect, right? This huge data lake where then all the indexers, other DApps developers can actually source their data from And then if you route it through Oracle systems like Chainlink or others, it actually allows some very smart use cases where you can then access some APIs which you usually can't access through Web3 because you're not allowed to do the foreign calls. But now that they are stored, like decentralized, validated, you can actually safely now retrieve the data from that. So we'll now jump into a quick demo and having a look of like what KYVE looks like in the wild. We've done through quite some iterations. So we started out being an Arweave-based project with Arweave-based smart contracts, and then noticed like the flaws of that system and the not production readiness, switched over to an EVM-based solution from that, but like the core logic always stayed the same. It's really just some development decisions we are doing on our end. So let me just hop into the demo. Here we go. I hope, perfect, that works. So basically you start off with our dashboard where you can see the pool funding, like pool delegations, you see your portfolio actions. It's like pretty basic overview. You could see the nodes you are running on your own if you're a node operator, and you can see your delegations. Maybe adding to the voting system, it's actually also quite a nice story how we had to introduce delegation to our system, because we were fully Arweave based, and on Arweave there is no gas cost on a smart contract, allowing us to really like spam the Arweave network with tons of transactions. And I think it was like last year, November-ish, we had like 10,000 nodes active in the system, which is absolutely great. But we just spammed the whole network. And we're like, okay, like now we have to actually artificially introduce those limits again, right? To deal with scalability of the underlying solutions we're working with. This is now the reason why we also introduced delegation to the nodes, to like make sure we have a limited number of nodes, but still have a high security in the network. So you can see with this demo wallet here, we've done quite some delegations, and we've also funded some pools. And I will talk about the pool funding in 1 second as well. We have introduced the governance as well, where you can see where you can vote on pool configurations, you can vote on payout rates to like really make all the pools like configurable. And then if we look at the pools, you can see here we have like a bunch of EVM chains here rolled out. We have like Moonbeam, Avalanche Seed Chain as well, Aurora. And you can see here that they all use the same EVM runtime. Oh, that's a bit late. We all use the same EVM runtime because all those chains are EVM compatible. So the actual action of storing the data is the absolute same for all of those chains. Like there is no technical difference in that. And then, as you can see, Injective is something we rolled out a few days ago. We, of course, use a different runtime for them because they have some different approaches of storing it. And if you guys are a developer and you would like to store the data you are using, you can come up with your own runtime. And you could, for example, store, well, on the Avalanche seed chain, what's like some aggregated values you're working with. Like you can sum them up, you can do stuff like that. We'll jump into this in a second as well. And if we now look into the Moonbeam pool, you can see again here the runtime. You see how much have we indexed, meaning that starting from block 0, we now have 40% of the whole Moonbeam chain stored on Arweave, validated in archive, which is then accessible for developers as well. Some other basic metrics to see around here. You see the portfolio with the pool funding, the delegation, and so on. And the pool funding is, I would say, the core mechanic of how the KYVE tokenomics works. So the idea is that a developer or a foundation, right, has the need to get access to the data, so they write their own integration, roll it out, and then provide the initial pool funding. And then what will happen is that either the foundation itself utilizes this data in some way, someone else maybe builds a multi-chain block explorer or some other like cool use cases, token bridges, things like that. And then, of course, they build a business case, right, on top of the data we have stored for them. And although data is like free to access for everyone, you really want to make sure that you don't lose access to the data, because it's always a stream of data. And let's say, right, multi-chain block explorer, super cool example. You build it, and suddenly you don't want to say users, well, actually, we can show you the latest data. So you're always, of course, incentivized getting some new KYVE tokens and providing it as a pool funding. And you can see here this in the funders tab. I think this is actually our address right here, which has the most pool funding. And then the more you go down, it's just some users in the testnet funding the pool with KYVE tokens. And then every time a piece of data gets validated, some of the pool funding gets reduced and paid out to the nodes in the system, basically as on a normal chain, I think would be gas costs, right, to compensate them for doing the work here. On here, you can see all the nodes which are active. You can see how many blocks they have created in here. And we had to limit, this is what I said before, I think it's now limited to 50, yes, it's limited to 50 nodes in the system, just to make sure we still have the scalability on the underlying subchain. And then on the activity tab, that might be super interesting, you can see here, the Arweave ID with the data in there. You can see which node uploaded the data. So what happens is, once a piece of data has been uploaded, you then basically search for the next uploader, and then he uploads, like a round-robin system. You can see the votes here, so 56% have voted in favor of this piece of data, meaning that it's valid. You can see how many Moonbeam blocks have been in the bundle and the time when it got created. The chain is a bit halting right now on that. That's the reason why there has been no stuff happening for 11 days. But if we look into the Arweave ID here, you can see it's very just download that. There we go. You can see it's very compressed or condensed data. Maybe actually it's not smart opening here because I'm afraid my Mac might freeze then, but it's basically like an editor. It looks super weird. Like basically developers have to do some work to do the indexing on that. But this is like the base idea of like how the pools work. We can look into the Avalanche C-chain pool as well. Has been 4% here. Pool ID looks exactly the same. It's the same concept behind all those integrations and the way it works. And so, because I already said the data is super condensed, it's like compressed to make storage more efficient and things like that, we at KYVE have developed a sub-product called Warp, which allows developers to get more easy access to data through a GraphQL indexer. And it looks like this. The cool thing about it is that you can access all of the KYVE pools from one query endpoint. So in this example, right, we would query the first blocks on Avalanche and Moonriver and Moonbeam, whatever. So we query for blocks here, right? And we filter the blocks where the field number is less than or equal to 5 on different sources. So we're querying this on Avalanche, on Moonriver, and on Moonbeam. And if we now execute this query, you can see here that we get blocks 0, 1, 2, 3, 4. Well, and 5 for Avalanche, for Moonriver, and so on. And of course, for the developers here, which are familiar with GraphQL, you can of course now extend the data you would like to access to like all the sub-attributes which are in there. And this is only possible because we are in this like novel position at KYVE, knowing what the data looks like before we store it. So it's much easier for us to index it the other way around, right? Because when you're a developer, you specify what the data format is. So we just basically take this information and then are able to build it up the other way around. And writing an integration is also very straightforward, very easy. So what we've done at KYVE is we have developed this core package, which is handling all of like the voting, all of the bundles for you. So you as a developer really only has to care about how do I get the data from my source, and that's really it. And how do I want to validate it, right? And usually you can say, well, validation is like, is A equal to B, and that's it, right? That's absolutely fine. So the way it works here is this is the EVM integration, right? And what you do is you're just extending, well, the normal KYVE class, which is the thing we already pre-built. And then it's really just 3 functions. One is just the request, or like how do you request the API. If it's like that, you can see here we are querying by the block height. I get block with transactions for the height here. That's it. If you would query for like, let's say the European Central Bank API, which is sorted by date, you would just query by increasing dates. And then here's just like some increased bundle function, create bundle function, sorry, which just basically shows how you take the data you have downloaded, you bundle it up, and then you just submit it, and that's it. There's just some helper function here to load it, and that's really it. Because in this case, we're using the pre-built validation function, nothing to worry about from our end. That's super easy. And actually, in the new release we're rolling out, we were able to boil this down to only one function, which is even cooler, basically. So what you then do is you just say, hey, how do I get this one piece of data, and what is the next key I would look for? So in case of EVM, it would be, how do I get the block for a given height? You return the data, and then you just increase the height by 1 for the next key. And it just goes on from 0 automatically all to the top. So yeah, super easy to access the data. You can work with any Web 2 API, Web 3 API, nothing to worry about from that side. And this also allows us, the team, to roll out like different integrations very fast, because like usually it's very well documented how to get the data of the source you're working with. So yeah, not much work, which allows us a lot. And then you bundle this, you would go through the governance here. Actually, I don't know if we have something set up on the demo environment here. No, unfortunately not. But usually it would be like a create pool proposal, and people would have voted on to do that. And as I said, the pools also have different configurations, like how much do you pay out, what are like some RPC endpoints you connect to, and things like that. And then, of course, the governance could also vote on that. If you guys would like to try out KYVE, I mean, feel free to just go to app.kyve.network. As up here, go to Faucet, and you can claim some tester tokens here via Twitter, and then you can just play around. You can like try to run your own node, which is also very straightforward. So we always try to like really focus on the developer UI, developer UX, making it as easy as possible to really set up everything. And I think that's maybe it from a demo perspective. And now jump a bit into like the roadmap of like what's happening, what's going to happen. And then, yeah, so there we go. Perfect. As I already said, John and I never had like like the vision or like the big intention to build something like KYVE. It really started out as a weekend project where we saw a Gitcoin bounty for bridging Polkadot data over to Arweave. We're like, hey, actually, you know what? That's some cool money for a weekend project. Let's do it, right? And this is how it all started. And then we showed it off to some community members. They really loved it. So we started to reach out to other ecosystems, and I think Avalanche was one of the first ones we talked to, and they also loved the idea, right? Because every project hits like data scalability problems, right? It's like it's tricky to handle it, especially like it's costive to distribute it and things like that. And so they all really fell in love with it. And then we did a pre-seed round early 2022, released the testnet you were seeing there, as I said, fully Arweave based in the beginning, very buggy, a lot of fun, a lot of sleepless nights. And then from there, we rolled out slowly over to EVM. I saw the power and solidity, but still storing the data on Arweave. Did a seed round, improved the UI and UX thanks to Julian and the others sitting down there at the team. And then, very recently did the protocol update where we also reintroduced the governance to really give the users more control. So our goal at KYVE, you can really put it like that, is like achieve real and like complete decentralization in every single step of it, because we look a lot into other ecosystems and we see a lot what's going on there, and we see a lot that much more stuff is more like marketing than it's actually like truly valuable decentralization. And so we're like, okay, we want to like build something sustainable, and so we have to focus on getting that stuff right. The next big thing on the roadmap is our incentivized testnet. It's going to start in a few weeks from now. It's going to be same UI with some exciting update changes, which is coming out 4th of April. So stay tuned. I'm not allowed to talk too much about this, but it's an exciting update. And then, of course, after that, it's really the road to mainnet with some TGEs, mainnet launch. And the way mainnet is going to look like is we're going to propose the integrations which have been working well on the incentivized testnet, then over, of course, later on to the mainnet to really make sure that, we store all the data correctly. And then, as I said, we partner with a lot of, or basically I would say any major L1 and L2 out there in the ecosystem. We see actually a lot of different target groups reaching out to us, so which we target, which is super interesting. So you have existing projects out there like an Avalanche, like a Solana, right? Which are facing scalability issues right now. I think on Solana, it's pretty well known, right, that like the Solana team is one of the only teams actually maintaining a full node, because it's just very expensive to maintain it, because it's a lot of data. And you can either focus on high TPS, which then gives you scalability problems on data, or low TPS, and then you can process a lot of data. And this is what Arweave is doing, right? Arweave has like 10 minutes per block time compared to Solana, where it's much faster. So you see both of the things there. Like Cosmos, Near, all the ones, and now we're also actually working with projects out there which are right now launching and have identified those issues on their own already, and are now reaching out to us like, hey, KYVE team, like, how can we do this and that? Like, how can we basically build KYVE in as like a native tooling, or like this like crucial middle layer for them? One example is, for example, like some NFT projects. It's like, hey, like we like to use this and that chain, but it's super expensive to store the metadata. Is it possible to route the metadata through KYVE, and we would just associate the transactions? Actually, this works. So it's like, it gives you a lot of flexibility in terms of like development, because you're not bound to like using some data format, you're not bound to using some programming language. It's like completely open for everyone to do. And I would say the next big thing is let's just jump into the Q&A session. I'm lucky that a few more people joined, so hopefully we can get a more rich Q&A session then. But feel free to ask any questions regarding KYVE or anything related to scalability, storage, anything. I see first thing that is awesome.
Thank you. Can you hear me?
Yes, it works.
Great. So you have mentioned that the KYVE is focused on the problem of solving storage problem, expensive storage on, for example, EVM-based platforms and so on. So do I understand correctly that KYVE is stepping in here as a kind of side chain on which the expensive part of the data can be stored externally?
Well, so yes and no. So we are utilizing other storage solutions for the cheap data storage offering, right? So right now we're using Arweave for the data storage. In future, it might also be possible that it's maybe a pool configuration saying, hey, actually, I would like to store my data on IPFS, right? Or especially in Arweave, it's not controversial, but it's a question of like, do I really need permanent storage for my solution, right? Maybe like, especially accounting reasons, right? Maybe 10 years is enough. Maybe I don't need to pay for like the full 200 years. So it's like really a decision you would have to do as a developer on that side. So, and then KYVE really is just the transport layer, right? The pipeline helping you getting data onto the permanent storage and then making sure it's validated. So it's like this, I like to say it's like the validation layer on top of the permanent storage.
Okay, thank you. But what exactly is the use case for validation? I mean, usually in NFT world, you just need to store somewhere securely your data for your NFT's metadata. And so what is the use case for validation?
Yeah, for sure. I think the very prominent use case on that is if you want to do like snapshots, for example, of a chain, you can store the snapshot on decentralized storage. But if you modify the snapshot on the way from like the source to the storage, it's still like incorrect data being stored permanently, which still has like the danger of being then loaded in and then basically serving some incorrect state. So it's really like really making sure that the transportation is correct onto permanent storage.
Got it. Thank you.
You're welcome.
Do you have any estimations how much the cost of the storage will be in the future? Like how much would be to store the whole Bitcoin chain there? Like let's say per gigabyte, have you made any kind of economic calculations?
Yeah, for sure. So as I said, like of course our storage price is going to be bound to the underlying storage price. I'm not too sure. I know on Arweave for quite some time. John, correct me if I'm wrong on that, but I think it was around like $7-8-ish per gigabyte. So of course you have this underlying cost which our network has to cover for the storage, and then of course you have the additional cost of validation, but this is set per pool. So let's say you have a pool where you would like to incentivize a lot of nodes to be active, right? So you could, of course, have a higher payout for that pool than for some others. But of course, it's going to be bound to the underlying storage. So if there, maybe in the future, right, there's like some decentralized storage solution where 1 terabyte only costs 1 cent, right? Then bridging over the data would be quite cheap as well, right? Or if, I don't know, there's like, basically because it's bound to the underlying storage, it's to that with the additional cost of like, how much do you want to pay for like the validation part of it? And of course, the node operators are going to be more active in the pools where they get higher rewards, right? So that's kind of the main idea behind the tokenomics of that.
I think I missed the beginning, but how would you differ from the graph as we had to call like to aggregate and do kind of a cache, if I'm correct, like a cache between the blockchain and the queries? Yeah. How do you compare with the graph, for example?
Yeah, so this is a very interesting relation I would say we have to the graph, because we are actually highly complementary to them. Like KYVE is a protocol, because the graph has to source all the data themselves, right? Like from nodes, you have to fetch it from there and things like that. You have to basically get the transportation right. So what they can do with actually KYVE is, instead of having to connect to nodes on their own, collecting the data on their own, they actually can just source the data we have already stored because they know it's correct, right? So they can source it from there much faster, as well as they can offer like maybe non-EVM solutions decentralized as well, because we have the data in this big data lake, and we're very happy for people to utilize it, right? Because then they build their business model on top of the data we're creating, of course, really kind of benefiting our tokenomics and the way KYVE works. And then also the graph has this cool feature which KYVE doesn't have right now, which is that they can give you the active state. So you can ask the graph like, hey, what's all currently active trading pairs on Uniswap, right? Like they can give you, because they do the calculation for every block height, they can give you that. While at KYVE right now, we can just give you the historical data. Like we can give you everyone which has been active and everyone which has been inactive and so on, but we cannot deliver like an active state. And that's like the big difference, I would say, between the indexing part, but then of course the data storage part is just highly, highly interesting for them to really source out from that instead of having to connect to something else.
And so if I understood well, without having like a deep technical background, the data that goes through KYVE is computed, and can be leveraged, for instance, by, I don't know, node operators like us in order to bootstrap, like get the latest state of a given network and have a much easier life, basically like setting up a validator. You confirm.
Yes, no, absolutely. Yeah, you can. So you can do a lot of things like that. It's like you can source like the data we have to like load it into your local database as a node operator, right? Running it from there. You can do computations on the fly if that would be needed, but especially for node operators, right? I think that's actually something someone did in the Avalanche space to actually basically prune their local database of the node, making it more cost efficient, and then just source the old data from KYVE, deliver it from there. Absolutely.
Okay, interesting.
No more questions. Awesome. Perfect. Well then, thank you everyone for attending and listening in. It was a lot of fun. Is there another question? Yeah. Maybe we can.
Yeah, sorry for the late question. As a Web3 developer, let's say I have my product deployed on different protocol. How do KYVE help me to basically have the same sort of Web3 events requested on Fetch in one place? You know?
Yeah, I see. So I think that would require you to set up maybe like two different storage pools, right? So you're talking about like a cross-chain setup, right? Yeah, exactly. So let's say you have like your data on chain B and some other data on chain B. Then of course KYVE, you either write your own integration where you source both chains individually, or if you're lucky and you're using like the Avalanche seed chain, for example, or like Solana, your data's already there and you can just basically retrieve it out of KYVE. And then you can use it in your like the app by just using, for example, our query backend, right? If you want to be really sure you route it through an Oracle, like Chainlink, and other ecosystems like that to really get the valuable data out of that. And then, of course, maybe some other cool use case I also haven't talked about yet is also analytics. Like, of course, you can use KYVE, right, to like take the data, source it from one point, get it into your local database setup, do some calculations on it, and then get that stuff going on as well. So it really depends on like what the use case is and what level of decentralization you need. Like sometimes it's important to like go all the way in if you use it in smart contracts, for example. But if you just use it from the UI and you say, well, it would be fine if in some cases, right, like it might not be correct or something, well then of course you can just use it through there as well.
Thank you.
Is this on? Okay. A question, what pain point or external dependency is affecting you the most as developing right now with this platform?
Test. Now it works perfect. So yeah, it really depends on the ecosystem you're working with. I think well, coming from Arweave, you have a lot of flexibility there because you're just working with JavaScript, which allows you to do a lot of things, but then introduces problems like determinism, especially on the smart contracts. Like how do you make 100% sure that like the action you execute is deterministic? Contract-to-contract calls were really tricky for us, and it's also like one of the main reasons why we migrated away from Arweave-based smart contracts to then Solidity-based contracts. And then this, of course, limits you sometimes a bit too much, where you have like the problems of, well, it's complex data structures and things like that. How do you be smart, and how do you really think about making it storage efficient, right? And then, so it's really like the decision of like, what do you want, what do you need in some cases. And then, of course, you also have like the underlying ecosystem reliabilities as well. So our current setup, it's an EVM contract deployed on Moonbase, which is the testnet of Moonbeam, and Moonbeam sits on top of Polkadot. So in theory, we introduce like another layer of reliability to Moonbeam, where we say, well, actually, if you guys do your job right, well, only then we can operate correctly, right? So it's like really like thinking about the benefits of that. And yeah, as I said, on April 4th, there's a big upgrade coming out of that to kind of solve those problems too. So it's like really exciting seeing how, yeah, also like the team's knowledge and team's experience has really changed with like the last year with like this view on Web3 and also working with the different ecosystems as well, getting some like nice insights of like how they work, how they roll, right? And what's the things on that. So yeah, that's, I would say it's like, it depends on the ecosystem you're working with. Exactly. Right. No, it's fine. Okay. Awesome. Well, if there are no other questions, thank you everyone for attending. It was a lot of fun. It was a great talk. And yeah, happy to see you guys around. We have a booth at the like main event thing. So if you want to connect like now or after the talk as well, feel free to just, yeah, hang out with out there. We're like 4 people all around. So yeah, happy to have a chat there. Awesome. Thanks.